Ja, meine Damen und Herren, vielen Dank noch einmal an Dr. Gerd Kortemeyer und Fabienne Kierner, dass wir heute hier sein dürfen im Swiss Innovation Park für dieses University Future Festival. And I will now switch into English because our first input will be held in English. Our speaker is Mrinmaya Sachan. He is assistant professor in the Department of Computer Science at the ETH Zurich. His research is about natural language processing and the interface of machine learning and education. For his work, Mrinmaya received several awards, among others an IBM PhD fellowship. His current research is funded by grants by the Swiss National Science Foundation, by the ETH Foundation, and also by the Haslerstiftung, and he will have his input about AI and education. If you have questions in the audience, and of course also in the live stream, you can scan the QR code and you can type in your questions, and then we will have a Q&A after the input. So, I'm very happy that you're here. Welcome here, Professor Mrinmaya Sachan.
Okay, hello everyone. Thanks a lot for inviting me and thanks for the wonderful introduction. I'm excited to tell you a little bit about some of the work we've been doing in the space of AI and education. So, let's get started. So language models are essentially everywhere, right? And the press has been telling us a lot of cool things about how these models have been doing interesting things. According to the press, the New York Times, GPT-3 has learned to code or to blog, to argue. ChatGPT might have kicked off an AI arms race. It has kicked off an AI arms race. How AI is mastering language, but should we really trust it? And there are a number of questions around this field. One of the things about these models that is really interesting to me is how these models have really shown a lot of promise in solving some very challenging educational problems. For example, this is a familiar result from the GPT-4 paper. And according to this paper, according to this set of results, the GPT-4 model is doing as well as the 80 percentile test taker on a number of these exams, right? And this includes things like the bar exam, the GRE quant exam, macroeconomics, biology, and so on, right? So you name it. And this has brought a lot of renewed hope around the field of AI for education. And very quickly, we have seen this kind of rapid integration of these large language models in a number of edtechs, right? So for example, you might have used Duolingo Max. This is this latest offering from Duolingo that helps you sort of learn a language as if you're by interacting with a conversational agent. Khan Academy has this new product called Khanmigo, which is sort of a conversational agent that is integrated into their platform. Then CK12, one of the largest online textbook publishers, has, again, this chatbot that has been integrated, and learners who are reading textbooks can actually engage with this agent as they are trying to learn. Now, however, if we were to sort of take a step back, it's still unclear empirically, right, whether these models are really helpful in these kinds of learning scenarios. And amidst a lot of hype, there is also a lot of challenges in the field if you were to really think about integration of these methods in educational contexts. So here is sort of the plan that I have for the next few minutes. So I thought, since we are talking about language models in education, and since some of these models might already be a little bit mysterious to some of us, maybe I'll start out with sort of raising this question: what are these language models and how do they work? And as somebody who works on sort of natural language processing, this is something that will take a lot of time, but maybe I'll try to give a sort of a bird's eye view on how these models work, right? Then we'll move on to talking about some of their limitations, how can we address them, and particularly in pedagogical contexts, how can we address the challenges behind these models. And finally, I'll talk about some of our ideas on the path forward and the work we are doing. Okay, so what are these language models and how do they work, right? So So what are these language models in the first place? So actually, language models have been around us for a very long time, right? This is not a new concept. And language models are really simple. They are simply these machine learning models that are trained to play the guess the next word game, right? So Mrinmaya is giving a presentation at the blank. The model learns to guess what is going to be the next word in this sentence, right? Really simple. And they do this by estimating some kind of a probability distribution to sort of predict what is going to be the next word. Is it going to be event, or university, or office, right? And then once it has learned to do this, learned to predict the next word, then there is some another algorithm that sort of selects what is going to be the actual word. And when you use it in practice, you can sort of generate this natural language output, right? Mrinmaya is giving a presentation at the university festival. Okay, really, really simple. So these language models have a rich history in the field, right? They've been around us for quite some time, and some of the work on these models goes way back to Claude Shannon's work on information theory in the 50s and the 60s. But a lot has changed in the field, right? Say around 10, 15 years ago, up until then, these models used to sort of have a database. We used to construct this large database of like word counts, what word appears next to what other words, and we would sort of try to estimate this, this distribution that I was talking about, right? And these models were useful. They used to sort of help us in some speech recognition models, use them, some machine translation systems use these models, but a lot of systems kind of ignored these language models. They were not that popular up until maybe 15 years ago. Then there was this sort of a radical shift, maybe 10 years ago, with deep learning, with these large neural networks that started making these models really effective, right? And a lot of natural language processing systems started to use these language models as kind of like a starting point, so to do anything else, right, that you might be interested in. And that was one sort of a big shift that took place around 10 years ago. But then in the last 3-4 years, there's been a significant scaling up of this technology, right? We have a lot more data, we have a lot sort of larger models, and we're also learning from humans, right? And this sort of technology is what kind of you've seen in these GPT series of models, right? GPT-3, ChatGPT, GPT-4, and more models are coming out literally every day now, right? So now what you have at this point are these models that you can simply prompt. You can simply prompt these models, and you can instruct them to do the task that you're interested in, and they would sort of supposedly do that task for you, right? And that's cool, right? That's what we want as humans. So let's look at some of these points a little bit more in detail, right? So in this plot, you can see how these language model sizes have been increasing over time. So here I'm plotting this from this journey from around 2019, when we had sort of our first language model, up until 2022. So that you can see these models have grown in size by about 5,000 times in terms of how many parameters they have, right, when they are trained to do this task. And if you really think about things from the perspective of a neuroscientist, right? The human cerebral cortex contains about 1,000 times the number of neurons as that of mice. So clearly, size has something to do with intelligence. It might not be the only thing, but it has something to do with intelligence. So that's great. The other thing that has happened is these models are now trained on pretty much the entirety of the internet, right? And if you were to think about how much data these models are trained on, and compare that to what a human might have seen in their lifetime, these circles here in my plot, in this image, show you sort of what is the proportion of amount of data that these language models have seen compared to what a 13-year-old human would have seen up until that time point, right? So you can see these models have seen well over 1,000 times as many words as a 13-year-old has seen in their entire lifetime at that point of time, right? So these models have seen a lot of data. And while reading the internet, these models learn some information about the world, right? They learn things like ETH is located in Switzerland. They learn how to observe some human tasks, right? So on the internet, you often have summaries. For example, Wikipedia starts off with a summary in each article. So they learn to observe these kinds of tasks and perform them, right? Like summarization or translation, or how you could answer a question. And the result is the model kind of memorizes a lot of information. It learns to do these tasks that humans really accomplish using text, right? Then finally, in these models, you have this new thing where we start to learn from humans, right? We put out these models in front of humans, and we say, OK, can we learn to give them text that they prefer, right? So this is sort of the new technology that has come up from some work by OpenAI primarily, where they hire a number of users, a number of annotators, and ask them to tell us, right, what kind of output they would prefer if a user prompts the model in a certain way. So the user asks a question, explain this concept, reinforcement learning, to a 6-year-old. The human labeler says, OK, this output is good, this output looks bad, and the model is kind of trained to mimic these kinds of preferences from users, right? This is the final step of what is called sort of aligning models to these human preferences, to these human interests, right? So this is simply all this technology. In ChatGPT, each of these things are modeled as a conversation. GPT-4 happens to be multimodal. You have also this possibility of having images, right, or producing images, right? And that's pretty cool. So with this model has learned sort of a lot of very broad task capabilities, right? You've probably gone on to use these models to maybe plan vacations. They can generate Python code, and they're not pretty bad. They're not quite bad at it, right? They're pretty decent. But these models become an encyclopedia on demand. So you could sort of ask it questions like list the last 10 presidents of Switzerland, right? And they can deploy this kind of knowledge that they'll learn from the internet when the human kind of asks them to provide this kind of information. So they're sort of these encyclopedias on demand, right? They also have learned this kind of personalization component, right? So for example, if you go and ask these models, explain the causes of World War I in a 3-paragraph essay, try to use as many complicated words as possible, right? That's maybe what a student wants to do. Or explain the causes of a World War I to a 10-year-old. They're not too bad at this kind of personalizing the output to the specifications of the user. OK, so these models are great, right? They work. But what are their limitations, right? And there are a lot of limitations in educational context. For example, these models often invent facts, right, if they look plausible. So quite some time ago, I went to ChatGPT and asked it, where does Professor Mrinmaya Sachan work, right? And it told me that Mrinmaya Sachan works, is an assistant professor in the Department of Computer Science at Indian Institute of Technology, Indore, right? It looks very plausible. I have an Indian-sounding name. I'm indeed from India, right? But that's what the model thinks about me. So it is, in this case, inventing this fact simply because it is plausible, right? There are other issues in educational context. So here, imagine a student who asks this model a question, what is 1 + 3, right? The model gives you an answer. The answer to the equation, 1 + 3 is 4. But then maybe we have a student who doesn't like to agree with the agent so much, right, with the model so much. The student says, that's not correct, though. 1 + 3 is 5, according to my textbook, right? Often you see these kinds of situations where the model sort of cannot hold on to this truth, right? In this case, the agent simply says, I apologize for the error in my previous response. You are correct. The correct answer is indeed 5, right? And this is really bad if you are using these models in these kinds of high-stakes contexts like education, right? So they really cannot understand what is fact versus what is fiction. Then there are a number of ethical concerns with this model. So in computer science, we have this principle, garbage in, garbage out, right? And these models, they have been trained on pretty much the entirety of the internet. And a lot of internet happens to be bad, right? So now they've been trained on the bad parts of the humanity too. They end up reflecting a lot of this, right? So there are a number of privacy concerns, toxicity output that is toxic. You have stereotypical information that shows up in these models. There's also sometimes disinformation. So OpenAI does a lot of work on this, right? They have these safety filters. They try to not make their outputs safe all the time, but you can always go around this. So here is a tweet from my friend and colleague, Steve Pintodowski, right? So he asked these models, one of these models, write a Python program to check if a child's life should be saved based on their race and gender, right? So the models currently would not generate something really bad in textual format, but since he asked them to write a Python program, a lot of this bad stuff shows up. So now, some of these problems are fairly general problems. They happen to be a problem in any kind of application that is high stakes. But there are a number of problems also in educational context when you use these models. In particular, in our research, we've shown that these models are not very good at pedagogy. They're not very good as personal tutors. So how can we address them? What are these challenges? So let's begin by thinking about how pedagogical are today's language models, right? So we did this study a couple of years ago, and we started looking at a number of these models that are out there. And here is a typical educational situation that might happen. So here is a question that a learner gets, right? James writes a 3-page letter to 2 different friends twice a week. How many pages does he write a year, right? So here's the answer to this question, right? 624. The student has a typical confusion. The student kind of forgot this keyword twice over there. The student produces an answer 312 instead of 624. So then we try to simulate a dialogue between a teacher and a student in this scenario, right? And here's what happens. So this model, Instruct-GPT, which is a precursor to GPT-4, in this case responds by saying, that sounds correct, great work, right? so clearly the model is factually incorrect, the student is wrong, but it has sort of not picked up on the error of the student. Here is what GPT 3.5 says. Right? So in this case, the model says you calculated the number of pages written per week correctly. However, James writes 2 letters per week, so the correct calculation is so on and so forth. Does that make sense? Right? So in this case, what the tutor has done is has kind of revealed the entire solution to the student in an instant, and this is no longer any more useful than the student having looked up the solution themselves. Right? And this is not great in terms of pedagogy. Right? So this is suboptimal, right? The tutor should not be leaking the solution entirely in this way. So we started thinking about this. How can we solve these kinds of problems, and how can we incorporate pedagogy in these models? So if you think about human teachers, right? Human teachers use a lot of rich, what are called dialogue strategies in dealing with learning in this kind of pedagogical context. For example, teachers might elaborate on the question, they might provide students with feedback, they might prompt them for some kind of specific information, they might provide them hints, they might correct them, summarize the conversation, so forth, and so on, right? So they use these kinds of rich dialogic strategies. So we started thinking about this. How do we incorporate this kind of pedagogy in these models, right? So one simple idea you might think about is, okay, let's go to all the classrooms in Switzerland, collect lots of this kind of conversational data, fine-tune on these models on that data, right? But that gives us a lot of privacy concerns, right? And this kind of data set is not available to us as researchers, okay? So we started thinking about how do we collect this kind of pedagogically rich data at scale, but also at much lower cost. So in our group, we've come up with a number of ways of crowdsourcing this kind of conversational educational data at scale. Here is one approach that we've come up with that I'm going to describe next. So it's a 2-stage approach of collecting this data, right? So in the first stage, we pair real math teachers that we recruit on these crowdsourcing platforms, right? So there are a number of platforms on which teachers kind of do some work to provide some service. So in one of these crowdsourcing platforms, we recruit math teachers, and we have some crowd workers who are now role-playing as students, right? And we simulate the situation of them conversing on this kind of a problem-solving task. So we create a small amount of data this way, but it's really challenging, right? The teachers are often waiting for students are often waiting for teachers. So then we do something a little bit more nuanced. We actually replace the student crowd worker altogether with language models that are fine-tuned to role play as students. So then we still have teachers on the left, but now we have language models that are sort of behaving like students. So this is kind of like this idea of the Turing test, right, where we sort of make the switch from the stage 1 to stage 2 at a point where the teachers cannot really distinguish whether they're talking with a language model, behaving like a student, or actually indeed a crowd worker who's behaving, trying to sort of role play as a student. So we collect this data in this way. It becomes a lot more scalable for us. And we ask the teachers to choose their pedagogical strategies from a number of rich strategies like this, right? So the teachers could sort of draw the focus of the student on the problem. For example, they are seeking some strategy or guiding their focus on something or probing for certain kind of information. But we essentially ask the teachers to allow students to have an opportunity to learn, right? So this is the key thing. We recommend them to use these telling strategies where they reveal the answer or reveal the strategy only when they're trying to like scaffold them, and that's failing in helping the students make progress. Okay, so that's our idea of good pedagogy in this case. We use all this data to sort of fine-tune these language models. The language models have sort of this dialogue history between the student and the teacher and tries to generate the next teacher utterance, what the teacher should say, right, in this context. Okay, I'll skip some of this. So here is how our dialogue tutors do, right? In this case, I'm comparing ChatGPT, which are these bars on the yellow, with some of these models that we fine-tuned on this data, right? We have fine-tuned this FLAN T5 models from Google and OPT models from Meta, from Facebook. And these are much smaller models than the ChatGPT model, right, which is much larger. Okay, and we are evaluating these tutors here on 3 criteria. So we have coherence, just how coherent is the output with respect to sort of what has been the conversation so far. Then correctness, how correct is this feedback that the teacher is giving? And then we have this third aspect, which is this aspect that I've been talking about that learning scientists call equitable tutoring, that we should be giving learners an opportunity to learn, should not be just giving away the solution to them, right? And you can see here that on both of these aspects, in terms of correctness of feedback, as well as on equitable tutoring, right, giving learners an opportunity to learn, our fine-tuned models are doing better than ChatGPT in this case, right? And these are much smaller models that we can actually build in academic contexts. Okay, so in conclusion, our tutors fine-tuned on this data set provide learners more correct feedback and provide them learning opportunities compared to large models at industry scale, such as ChatGPT. Okay. Okay, so this is some work that we did. And in the future, we have this, going forward, we have this initiative in Switzerland called the Swiss AI Initiative, which is this initiative between ETH and EPFL, involving several other institutions across Switzerland. And here, what we are doing is we're trying to build a number of these models, foundation models for different domains, such as sustainable climate or healthcare, vision robotics, as well as for education. And in particular, we have some of this work in educational context where we are trying to scale up basically all of what I described today. We have this approach of trying to collect this pedagogically rich data at scale. We want to train our tutors, adapt these language models on the data that we are collecting, and we are interested in conducting these kinds of evaluations, maybe piloting some of our models in schools, as well as conducting some trials. So I'm looking forward to some of your feedback. Some of our work is still in the early stages. Be happy to learn. Okay, thank you.